All right. Welcome to the Thursday before break. So let's enjoy some quadratics and identifying quadratic properties. Well, this one's kind of nice. It's looking at the visual stuff. But it's also laying down the basics and the foundation for what we want to do. So let's take a look at our lesson. We are going to be looking at all these different standards here. We want to be able to explain a parent function for a family of quadratic functions. And if you see f of x, f parentheses x here, it just means it's kind of like a substitute for y. It's like a mechanical way of representing y. So like y equals x squared. The second objective is that we're going to be explaining that the minimum or maximum of a quadratic is called the vertex. That's one that we're definitely going to highlight a lot. And then we also want to be able to estimate the vertex of a quadratic function by evaluating different values of x. So let's get started. Well, for a polynomial, which expression is a quadratic polynomial? Is it A, B, C, or D? And I want you to focus not as much on the word polynomial, but on the part that says quadratic. Which one represents a quadratic? Alright. You might guess, and if you were correct, you would guess D. Quadratic means square, like x squared, x to the second power. Alright. Tricky. Well, which of these expressions is a linear polynomial? Is it A, B, C, or D? 3 seconds. Alright. It is A. A is a linear binomial, really, but it's linear, and that's one of the key things. Okay, we're going to be working with quadratics more heavily here. And first we're going to talk about what a parabola is. This is a new key term that you're going to be hearing a lot for the rest of this unit. Well, a parabola, it is a U-shaped curve that is the graph of a quadratic function. We're going to be making parabolas when we get back from break, but what we want to do is identify a bunch of key aspects of this U-shaped curve on a graph. And see, we have this thing identifying a parent function, and we're going to be looking at all the different characteristics. See, for quadratics, the family of quadratics, they all look very similar. All of them have this U-shaped curve where they come together at you could call it a point, but it's not like a corner. It's actually continuous. It's nice and neat, kind of like a bowl. You know, it's very cup shaped, very perfect in its shape. But we're going to talk about all these different parts, and one of the things that we will emphasize is that we want to. Oh, here, let me go back to this. There we go. We're going to be looking at an axis of symmetry, a vertex, and identifying a minimum or maximum in our given problem. So let's take a look at some parts here. Let's jump into this. We can actually identify just from looking at the equation, and actually we'll be doing that more. What is that? In part 2. But the first part of this lesson is really going to be looking at the visual parts of a graph. So first, I want to just talk a little bit about symmetry. And you know, we've talked about symmetry a little bit in the past, but okay. Now, symmetry, it's about when you have an image, something should be able to be split equally into symmetric or exact parts so that one is a mirror image of the other. And that's why we have this dotted line. Well, I want to give you an idea of like an axis of symmetry here. If you look, we have this line that we're going to be referring to. This is in a quadratic problem where, see this U-shaped curve. Think about U. The shape in itself, or the letter, it's a perfect shape because you know it splits very nicely in the middle, so perfectly that we call this line an axis of symmetry. And we're going to be identifying that using let me see, well, we'll be looking at that, trying to figure out just the center of the graph. Next, we'll be looking at the vertex, and we have a couple key parts here. Alright, now I want to talk about what a vertex is. A vertex is the line, or sorry, where the curve is actually coming together. So like if you look in the center where you have the one side coming down and then the other side coming down, they meet at this central point. This is actually at -4, +1. And this is... Alright, so I want you to focus on the shape of this parabola, because it kind of comes together like, well, let's say if it were a really steep half pipe. It's it's facing, it goes down in the center and then goes right back up and then goes down in the center right back up. Well, if this is facing down, then actually we're going to talk about how we have a minimum, since it takes you to this minimum point here. Whereas we'll also be able to identify pictures where we have a maximum. So, alright. Now this problem, it's asking us to identify what the axis of symmetry is. Well, looking at the graph, we can identify that the axis of symmetry is... The axis of symmetry is right in the center, and you might notice that it's at 3. We have this line where your parabola splits perfectly at x equals 3. So by the way, it's always going to be x equals, so we'll say x equals 3. If you give me something that just says 3, that's not enough. I need x equals 3. Okay. What is the vertex? Well, the vertex is going to be this point, and this is kind of like, well, actually different from that previous problem that we looked at. Notice how this graph is actually facing down. It's more like a very steep hill. Or maybe you could think of like the inside of a cave coming to a very high peak, and then, this is different than the one that we just looked at. But as far as the vertex goes, a lot of times you'll see me put a V and then the order pair. But this one I'll identify as 3, and it appears it's at -2. So 3, -2, that would be our vertex. And then we want to identify if this is a max or a minimum. Well, based on this picture, this reaches a highest peak. So I would call this a maximum. Okay. Got our 3 points there. 1, 2, and 3. Cool. Let's advance. Okay. Looking at number 2, we want to find the axis of symmetry for this one. And again, looking here, we see we have the axis of symmetry is in this central part, but it's on the line x equals 2. You don't have to draw the axis of symmetry, but at the same time, I would recommend it, especially for you guys learning this the first time. But yeah, your axis of symmetry is at x equals 2. Okay, what is the vertex? The vertex, just a hint, your vertex, the x-coordinate, is always going to be the same as the x value from your axis of symmetry. So we have 2, and then where is the y value? That's at 1. So the vertex is at 2, 1. Alright, we have 2 here. So x equals 2. The vertex is at 2, 1, and we need to identify if this is a maximum or a minimum. Now again, this is like the top of the curve. Exactly. So that is going to be another case of a maximum. Alright. Cool. I like it. Okay. Now, number 3. We want to figure out what the axis of symmetry is again. And you can see this graph, it is kind of steep, but we can identify that the center is on that line x equals 2. So, once again, remember, I need the x equals in front. I can't just have 2. 2 is a number, and x equals 2 is a vertical line, which tells me about that splitting line. Okay, what is the vertex? Well, the vertex is at this point here, and that is at 2, -3. Alright, 2 down. Let's see, is this a maximum or a minimum? Now looking at this graph actually goes down and then comes back up. So since it goes down in the first place, then it's going to have a minimum. Alright. Awesome. Alright, number 4 coming up. So, let's take a look at this. We want to find, same 3, axis symmetry, vertex, maximum or minimum. Well, looking at this, we have our axis of symmetry at, this line appears to be at x equals -4. So let's put that in. Okay. What's the vertex? Well, the vertex here, that appears to be at -4, +1. Alright, and got those. Now, the last one, is this a maximum or minimum? That is a minimum. Cool. I like it. Now, let's talk about the Y-Intercept. Well, the Y-Intercept, that is, so let's say, here, I just want to show you guys. Recall that you have a y-axis and an x-axis. The y-axis is the one that is vertical, it goes up and down, and the x-axis goes left and right. So looking at these two, we can see where the parabola crossed the y-axis, and it's at this point. Anytime you write your y-intercept, you gotta make sure that you identify it as an ordered pair. So for this, your y-intercept would actually be 0, 1. Okay, make sure to label it as an ordered pair, please. Okay, so, like for number 5, looking at this graph, we have the equation above, but if we look at the graph, what is the y-intercept for this function? Well, it appears that we have our y-intercept at, crosses here, so the y-intercept is at 0, -6. Okay. What about number 6? We want to find the y-intercept here. Now, so when you're finding your y-intercept, I know we have this whole parabola. We've been talking about all of this stuff. You have your axis of symmetry, we have our vertex, but the thing is, we don't need to know about that right now. All we need to know, it says what is the y-intercept. And just remember that the y-intercept is always going to cross this y-axis going up and down. So, where does this cross at? It looks like it crosses at 0, 5 here. So, that's what we will say. The y-intercept is at 0, 5. Alright. Cool. Now, number 7. This one, you know, sometimes they can be kind of hard to identify, but if we take a look at this, let's see, where does it look like number 7 has its y-intercept? This appears not quite at -10. This one looks like it hits more exactly at 0, -11. Now the truth is, you can actually look at and see how we have this -11 there. That is not just a coincidence. That is exactly one way where we can identify what our y-intercept is. Okay, well, moving on to x-intercepts. Those are going to be the points where the parabola crosses the x-axis. So we have, you know, sometimes you'll be able to identify 2 exact ones. Sometimes, you know, if they're exact, for now, I will have you identify them. If they don't fall perfectly on points, then I just want you to identify the exact values. So, like these here, for example, we would say these are at -4, 0, and where's the other one? 0, 0. We need 2 of them because we have 2 x-intercepts. Alright, sometimes you will have 2, sometimes you'll have 1. It really depends on the problem that you get. So, let's see, let's find the x-intercepts for this problem. And then if we look at this parabola, where does it cross your x-axis? Okay, at these 2 values we have x-intercepts of 2, 0, and what else? 6, 0. So there are our 2 solutions for this one. Alright. Now, let's try putting it all together. So, I want you guys to try it out. Find out what is the vertex. Well, the vertex is always going to be on that axis of symmetry. So we got to be able to identify the axis of symmetry, but at the same time you should be able to find your vertex because it's always going to be that coming together point. So that is at, what's the value? Remember, make sure to go on your x-axis first. We should say this is at +1, and then we could put the -4. So 1, -4. That's the vertex. What's the y-intercept? That one is at 0, -3. And finally, do we have x-intercepts? And if so, what are they? Let's see, we have x-intercepts. Those would be at -1, 0, and 3, 0. So we found our 2. Alright. Nice. Last one here. So, we want to identify all those 4 key parts. What's the vertex? Is it a maximum or minimum? What is the axis of symmetry? What are the y-intercept and what are the x-intercepts? Alright, take a second, see what you can fill out. When you're ready, take a look. Okay, so, man, I don't know what I keep doing here, but if you look at all these, I hope the circles didn't cause any confusion. But we have the vertex, which is at -2, 1. That's the, I'd say, the most important point that you need to know in a parabola. Then, when you ask the question, is that a maximum or is it a minimum? Well, it is indeed a maximum. That shape is facing down. What is the axis of symmetry? The axis of symmetry goes through the vertex, and your x-coordinate is -2. So the axis of symmetry is x equals -2. Now what is the y-intercept? It crosses your y-axis at 0, -3. And the x-intercepts that we found, they are exact, and we have -3, 0, and -1, 0. So please make sure when you get a problem like this, you identify as fully as possible. Very thorough and complete with your answers. Alright, time for the worksheet, and good luck.